Welcome back to Nature in Code. We're in chapter 3, and in the last video, we just did an amazing thing. We visualized in the browser our genetic drift simulation using a plotting library or graphics library, if you will, called D3. Freely available in JavaScript, runs in any modern browser. And as we said, when you reload this document here, then you'll see how amazingly fast both the calculations, the simulation, and the visualization is. And so that's really a remarkable thing because not only do we now have a way to visualize things, but it runs without installing anything. It runs in any modern browser. So this runs in all of your browsers that you're using. It runs on any modern smartphone. It runs on any tablet. And so I think that's really a great way. And I believe, I actually strongly believe that in the future, pretty much any graphic on the web, any sort of certainly visualization of a scientific process will essentially be in JavaScript for these reasons and many other reasons. However, one thing I want to talk about now in this lecture is to do that, we had to use something that we called an array. And in this video, I want to talk about what this array is because it's something that's going to be very, very important. And I'm going to do this here in the console, directly in the console. And so open the developer JavaScript console or whatever the menu path is in your specific browser. And now let's look at the code that we used before. We had a line like this that said var a, or in our case data, equals, and then we had these empty brackets here. So that is now an array. It is an empty array, so if you type data, then it'll just show you this empty array. You can push elements into this array by saying data.push. And again, data is now just a variable name, so you can call this whatever you like to. So let me push here a 3. Okay, just one value. Now, if I now look at data, well, it has one element, and that element is 3. So let me go ahead and push another element. Push. Let's say I'll push 5. So now the data array has 2 elements, and the elements are separated by commas. Let's do this one more time. Data push, I'm going to push a 9 in here. Whoops, this should be push. And here's data. All right, so that's an array. It essentially stores values, any value really, but it stores many values, however many you want essentially. And so that's great if you want to keep a bunch of data in one place, rather than setting up lots and lots of variables, you can just set up this one variable and store the array in the variable. In reality, of course, you're going to have very large arrays that have hundreds or thousands or sometimes even hundreds of thousands of data points. In our simulation over here, the data array that we're essentially plotting here, whose values we're plotting here, is an array that contains 1,000 elements. So let's go back to the console. And let me reload this just to get a new empty console. Another way to do this, you could also just initialize the data array, or any array really, with values. So rather than having an empty array and then saying data push, data push, data push, you could just say, I want the values 5, 3, and 9 right from the get-go. And so if you now say data, again, you have these 3 elements, 5, 3, and 9. And then, of course, you could later still add more elements if you wanted to. So data push 8. And now data has this element as well. And of course, I don't want to give the wrong impression. These elements don't need to be unique. I mean, I can just push 8 again, and now data has these 2 8s at the end. All right. So now this is an element. This is an array with 5 elements, right? First element is 5. Second element is the number 3. Third element is the number 9, and the last 2 elements are the number 8. There's a really handy way to figure out how many elements your data has. It's just the dot length property. So if you just say, whatever your array name is, dot length, that will give you the number of elements. And of course, that is 5 here, and that's correct. Now, perhaps the most important thing, how do you access these elements? And this is where the major array gotcha comes in. Let's say you would like to access the first element. You would somehow like to work with the first element here in this data array. So you would simply say data, and then again using these brackets, you would now here indicate which element you want. But the slightly confusing thing is, if you're a programming beginner, is that the counting here starts at 0. So the first element is actually at index 0. Okay, so if I want the first element, I have to say data 0. Correspondingly, if I want the second element, I need to say data 1. And finally, if I want the last element, I can't say data 5. That would actually be undefined. Even though I think, oh, I have 5 elements. No, the last element here, this array, is data 4 because we start counting at 0. And so this 0-based counting can be a little confusing, or it takes a little getting used to if you haven't been exposed to programming before, but almost all programming languages use 0-based indexing. All right, I want to show you something else you can do. So what if you have a bunch of elements in an array and you would like to do something now with each of these elements? You might have hundreds or thousands or tens of thousands of elements. Well, you can now combine two things that we've learned. One about iteration using for loops, and one about arrays and indexing. So let's say, again, you have an array here called data, and you might have some values in here like 5, 3, 7, 9, and 8. And so that's an array with 5 elements, keeping it small here so that we have some space here. Now I can iterate over this array. So remember iteration, we learned iteration through the for loop, which we would set up like this for some counter variable here to initialize it, usually I, and then we have some condition, and now we can say data.length, because data.length, remember, tells you how many elements you have in an array, so this would be 5 in this case here. So as long as I is smaller than 5, and then of course I have to remember to increment the counter variable here. It should be like this. All right. So we used to do things like console log. Let's just print this I variable, this counter here. In the console, and if we do this, of course, we get 0, 1, 2, 3, 4. We've done this before, but now if you look at this, you'll realize, oh, this is actually very handy, right? Because these happen to be the indices of the elements in the array. And so rather than just printing the i's, let's now use I as an index for the elements in the array. Okay, so we're going to say data and then index I. And as I said, I is going to be 0 in the beginning, 1 in the second iteration, 2 in the third, and so on. And that'll give us exactly these 5 elements that we have here in the array: 5, 3, 7, 9, 8. So that's how you iterate over an array, and that's going to come in quite handy. So I want to mention one more thing about arrays, and then I'll stop. But this is incredibly important. You can store anything in an array. So I just gave you an example where I only stored numbers like this, right? I have 3 numbers here, and they're stored as 3 elements, 3, 5, and 7. However, you can add elements that are not of the same type. So I could, for example, add a string here. So I'm going to push the string hello into this array. And now if I look at data, yes, I have numbers and I have a string here. So you can mix elements however you want to. This gets really, really interesting when you think about adding another array. So I know this can be a little daunting at the beginning, but an array can contain other arrays. So I'm going to make an example. Okay, I'm gonna create a variable here called a. It's going to be an array and it's going to have 3 elements. Okay, let's say 1, 2, 3. I'm also going to create a second array, and it'll have the elements. Oh, it doesn't matter. Let's do 9, 8, 7. Okay, and now I'm going to create an array that I'm going to call C that contains as elements these other 2 arrays. So if you look at C now, C is an array and it contains 2 arrays. And each of these 2 arrays has 3 elements. The first one has 1, 2, 3, and the second one has 9, 8, 7. So this is what we call a 2-dimensional array. So these are 1-dimensional arrays because they don't contain any other arrays. They just have elements that are not arrays. But sometimes arrays have other arrays as elements. And now this is a 2-dimensional array. And of course, in principle, you could go crazy and this array could again have other arrays, and those arrays could have other arrays. You could have 3-dimensional or multi-dimensional arrays. I don't want to go there at this point, but it's important to realize that you can do this, and we'll actually use this in the next lecture, because at the moment here, we are looking at this line here, which is essentially just a visualization of the elements in our 1-dimensional array that we call data. What if I would like to plot 2 or 3 or 10 lines? Well, then I'll actually need to have multiple arrays that contain the results for each simulation run. And I might want to store all of these arrays in one sort of overarching array. And that is going to be then a 2-dimensional array, because that array will contain other arrays that contain the data. So that might take getting a little used to, but if you see here how this works, this is actually quite simple. Just keep in mind that an array is just a set of elements, and these elements can be numbers, they can be strings, they can be booleans, they can be whatever, which means they can also be other arrays. And in that case, you would have a multi-dimensional array. All right, so I'm going to stop here. This tells us everything we need to know about the arrays for the time being. I'll see you in the next video.